Percent questions rarely beat you with arithmetic. They beat you one decision earlier. Which value is the base? A final price tempts you to subtract. Two changes tempt you to add the rates. Equal percentages tempt you to cancel them. In this lesson, for original SAT-style problems, turn all three traps into one method. Translate every percent change before calculating. An increase of a percent becomes 1 plus r as a decimal multiplier. A decrease becomes 1 minus r. Moving forward means multiply. If the problem gives the final value and asks for the original, reverse the motion by dividing. For successive changes, multiply the multipliers in order. Right. Final equals original times multiplier chain. That line tells you the operation before you touch the calculator. Original known, multiply forward. Final known, divide by the entire chain. The chain also gives the net change. Subtract 1 from the combined multiplier, then convert to a percent. Problem 1. A backpack sells for $84 after a 30% discount. What was the original price? Do not calculate yet. Identify the multiplier and the direction. A 30% discount leaves 70%, so the forward multiplier is 0.7. The equation is 84 equals original times 0.7. Divide to get $120. The reasonableness check is immediate. The original must be above 84, and 70% of 120 is exactly 84. $58.80 applies another discount to the sale price. $109.20 adds 30% of 84, using the final price as the base. $114 simply adds $30. Reverse percent questions do not ask you to reverse the sign. They ask you to reverse the multiplication. Now the base changes between steps. If a quantity rises 25%, step 1 creates a new base equal to 1.25 times the original. A later 20% decrease is measured from that new base, so step 2 multiplies by 0.8. The combined multiplier is the product, not 1 plus 25% minus 20%. Problem 2. A club has 240 members. Membership increases by 25%, then decreases by 20%. What is the final membership? Start with 240. The increase gives 300. The decrease then gives 240. Here the quantity returns exactly to the original. The shortcut is 1.25 times 0.8 equals 1. 25% up and 20% down cancel, even though the rates are different, because the multipliers are reciprocals. This special pair is the opposite of a common trap. Equal percentage increases and decreases do not cancel. If you rise by r and then fall by r, the combined multiplier is open parenthesis 1 plus r close parenthesis times open parenthesis 1 minus r close parenthesis, which equals 1 minus r squared. The square is positive, so the final value is always lower than the start whenever r is not 0. Problem 3. An account starts at $500, increases by 18%, and then decreases by 18%. The final balance is what percent less than the starting balance? The chain is 500 times 1.18 times 0.82. First, 500 becomes 590. Then 18% of 590 is $106.20. So the final balance is $483.80. The combined multiplier is 0.9676. 1 minus that multiplier is 0.0324. So the final balance is 3.24% less. Choice B. The shortcut predicts the same result because 18% squared is 3.24%. Visually, the first increase adds $90 because the base is 500. The later decrease removes $106.20 because the base is now 590. Same rate, different amount. The larger base on the down step creates the loss. The hardest version combines both ideas. A quantity is decreased by 15%, then increased by 20%, and the final value is $489.60. The original is unknown. Build the forward chain first, then divide by the chain once. Problem 4. After a 15% decrease and a 20% increase, a quantity is $489.60. What was the original value? The forward multipliers are 0.85 and 1.2. Their product is 1.02, so the two changes produce a net 2% increase. Divide $489.60 by 1.02 to get 480. Check forward. 15% off 480 gives 408, then 20% added gives $489.60. Under time pressure, ask 3 questions. First, what value is the base before each change? Second, is the problem moving forward from an original or backward from final? Third, are there multiple changes? Then write every multiplier in order. Multiply forward. Divide backward. For the net percent, combine first, then compare the combined multiplier with 1. Use fast checks. A discount means the original must exceed the sale price. Equal up and down rates must end below the start. A combined multiplier close to 1 means original and final should be close. And every keyed answer must reproduce every step, not just look near the final. These checks catch a wrong operation before it costs a full minute. One equation controls the whole skill. Final equals original times multiplier chain. Translate rates. Respect the changing base. Multiply successive changes. Divide when reversing. If these setups still cost you time, the $3 SAT percent change drill pack gives you one focused 18-minute mini test, a clean answer sheet, and fully worked solutions for all 12 questions. Open the product link in the description and start with the timed mini test.